In this video, you will learn how to simulate circuits with dependent sources. In previous chapters, we calculated mesh currents of this circuit. Let's do it again by using multisim. To add resistors, I click on the Place Basic button of the Components toolbox. Choose a resistor and click OK. I single-click on the workspace window to place the resistor and close the Components window as I use the copy and paste method to add other resistors. I copy this resistor by pressing Ctrl+C and paste 4 more resistors. Then I select resistors R2, R4, and R5 and rotate them by using the shortcut Ctrl+R. To add a DC voltage source, I click on the Place Source button and from the Power Sources family, select DC Power, click OK and a single left click to place it on the workspace. To add a dependent voltage source, I click on the Controlled Voltage Sources family and select Voltage Controlled Voltage Source, click OK and single click to paste it on the workspace. This time I select Current Controlled Voltage Source and click OK to add the other dependent voltage source, place it on the workspace and close the component window. In my circuit diagram, the current dependent voltage source is upside down so that the negative terminal is placed on top. In multisim, I can flip a component by right-clicking on the component and select Flip Vertically. Alternatively, I can use the keyboard shortcut Alt-Y. I quickly do the wiring between components and place the reference ground. For dependent voltage sources, the voltage of the source is dependent on the current or voltage of another part of the circuit. In multisim, you have to show this dependency by using the correct wiring. For the voltage-controlled voltage source, the voltage of the source depends on the voltage Vx across the R4 resistor. So I have to connect the input rectangle of the source to R4. For the current-controlled source, the input rectangle is of type current, and this is the current passing through R5 resistor. So I select this net and press the Delete key to remove it. I connect the resistor to pin number 2 of the input rectangle and connect the other pin to net number 2 of the circuit. In this way, I have placed the input of my current-controlled source in the direction of the controlling current. So the current passes through my dependent source. Wiring dependent sources like this will make your circuit look very messy and difficult to debug if there is a problem. So here I use a different approach. First, I remove the wires between dependent sources and controlling signal. Then I click on the menu bar, go to Connectors and select Global Connector. Add a connector and name it Vx and connect it to pin number 1 of the R4 resistor. I want to connect Vx to this point, so I add another connector here using the same name. You can easily do this by copy and paste. When adding connectors, because the net name will also change to the connector name, you will see the name twice. If you don't like this, right-click on the workspace window and in the Sheet Visibility tab in the Connectors section, uncheck Global Names, then click OK. I go to Place, Connectors and add another connector here. I don't need to name it because it is connected to ground and ground net is predefined in multisim. So I only need to select 0 and click OK. Then copy and paste it here. So Vx nets are connected together without using any wire, and zero nets are connected together as well. Let's go to the current controlled voltage source. I go to Place, Connector, and add a global connector on the open pin of the R5 resistor, and name it IX+. I will then copy and paste it to the input port of the dependent voltage source. When you use Ctrl+V shortcut to paste, before clicking on the workspace window to place the component, you can use Ctrl+R shortcut to rotate it before placing it on the workspace. I place another connector and name it IX- to connect the other side of the input port to the circuit. Now the current passing through the R5 resistor is also passing through the input port of the dependent voltage source. Now that the wiring of the circuit is complete, we have to change the component values before simulation. You already know how to change the value of independent sources and resistors, so I quickly change the value of these components. Before changing the value of dependent sources, let's review some important points related to these kinds of sources. Voltage-controlled voltage source, or VCVS, is a dependent voltage source in which the output voltage is determined by the input voltage and gain. The gain is the ratio of the output voltage to the input voltage. So if you have a source like this and the output voltage is mentioned as 3Vx, the gain will be the ratio of the output, which is 3Vx, to the input, which is Vx. Since the numerator and denominator have the same units, the gain will have no unit. In multisim, the voltage gain is indicated by E, and this is the value you have to enter for voltage-controlled voltage sources. In a current-controlled voltage source, or CCVS, the output voltage is determined by the input current. The ratio of the output voltage to the input current is called trans-resistance, and in multisim it is shown by letter H and measured in ohms. So in our circuit, the trans-resistance of the current-controlled dependent source is 2 ohms. Voltage-controlled current source, or VCCS, outputs a current value which is set by the inputted voltage level. The output and input values are related by a parameter called trans-conductance, which is indicated by letter G and measured in mho or Siemens. And finally, current-controlled current source, or CCCS, outputs current which is adjusted or controlled by the input current. Output and input currents are related by a parameter called current gain, which is indicated by letter F in multisim. Let's return back to multisim and change the values of dependent voltage sources. If I double-click on the voltage-controlled voltage source, there is a box to enter the voltage gain value. I type 3 and click OK. Now I double-click on the current-controlled voltage source and enter 2 for the value of trans-resistance. I want to find mesh currents of the circuit, so from the instruments toolbar, click on the measurement probe and add 3 probes, 1 for each mesh. If you don't like the default name, which is probe 1, double-click on the measurement probe, select the display tab and change the reference designator to I1, which is a more meaningful name for the first mesh current. Also, I am only interested in current value, so I click on the parameters tab and only check the current value. I click OK and do the same thing for the 2 other measurement probes. The circuit is now ready for simulation. I click on the simulation switch and multisim will display mesh currents. If you compare the simulation results with the values we previously found by solving algebraic equations, you will notice that the results are exactly identical.